Okay, the first thing, I try to get the okay, the first thing I want to let anyone in the Tech 1, you get a wrong room, okay? You need to go to Mr. Thai. And this the last time you able to get to learning about the theory for digital fundamental, okay? The thing is you don't have any more time. Next semester will be a summer only June month, very short. That's just for the AC circuitry and radio frequency. Okay. So any tech job in this semester, you don't have to do any assignment for tech work. Okay. That means we concentrate on tech job assignment.
Okay.
That's very good.
Thank you, Mr. Pham.
Yeah.
Thank you. That's a good news, Mr. Pham.
Yeah.
Yeah, it's a good
The
news.
thing is, we already completely done for Tech 1 in the fall. Okay. So now we just deal with the Tech 2.
Thank you.
Okay. So whenever they allow you guys to going back to the lab, you get two things. First thing is the people, student in this program, Tech 2 for a long time. You just take about 1 month to do your D lab, digital lab. However, any student from Tech 1 last semester, then you have to do two different labs. One will be left volt, you're not done. And another one will be D lab. Okay? So at this time, make sure you try to understand the digital. That's the key point. Okay? Forget anything about Tech 1. Only thing in the meeting, you try to be in the meeting with the Tech 1. Try to make sure you can get done for the quiz. Okay? Normally, I give it the quiz and I also try to solve it, the quiz to explain for you guys to understand, but it don't have to do upload or anything. Only thing you will be doing will be handout and also assignment for Tech 2 only. Okay?
Mr. Pham, let me make more clear for myself. So do we have to give the quiz of Tech 1 or no?
No.
No quiz, am I right?
No.
Okay, thank you so much. I appreciate it.
But the thing is, we need the students, so that's why we will still want you guys to be in a Tech 1 meeting. Okay?
Okay, thank you.
Yeah, no big deal. That's just make sure your memory will be good. Okay, so today, first thing we're talking about, basically, a lot of people already know, okay? Yeah, just for a minute. Okay, number system and codes. The first thing we're talking about a decimal number system. Okay, everyone already know decimal number. decimal number will be going from 0 to number 9. How many digits?
10. 10 digit.
Very good, 10 digits. So that's why they call a base 10. Okay, if you get 2 digits, that will be base 2. 16 will be base 16 so far. Okay, and 10 digits will be 0 up 1, 2, 3, 4 up to 9. And they will be a base 10. Okay, we have nothing to talking about decimal. You adding or you subtract, dividing, no big deal. Okay, and now we go into the binary number system. Okay, a binary number system, they get only 2 digits, either 0 and 1, and only 2 digits, so that's why they call a base 2. Okay, so when you say the number 10101, for example, that will be the binary. They only get 1 0, and that is the computer language. Computer only understand either 1 or 0, nothing else. Okay, so if you want to talk to the computer, then you have to using the binary. Okay, and now we go to the octal. Octal number will be 8 digits. They going from 0 to 7. Okay, that's octal. But normally now they're not using octal anymore. I think either octal or hexadecimal. That's another base. They're using hexadecimal. Okay, and now I'm talking about hexadecimal number system. They get 16 digits. 0, 1, 2, 3 up to A, B, C, D, E, F. Okay, and the base will be 16. Now, how come they need the either octal number or hexadecimal number? Who understand how? How come they need it?
Well, it's basically that it'd be a very long number if they didn't use hexadecimal or octal.
No, not quite. Okay, I said again. If you want to talk to the computer, you must be using the binary. 0, 1. Okay? However, very, very hard to using 0 or 1. They will be missing, they will be, a lot of things happen. You cannot. So that's why inside the computer, they get a circuitry. When you get the binary, when you get a hexadecimal, they will be converting into the binary so the computer can understand what you say. You see that? Human deal with the number 0, 1, 2, 3 or A, B, C, D, E, F. You cannot deal with the number 1, 0, 0, 1, 1, 1, 1. No. Okay?
So that just makes it easier for the programmer?
That's easy for the human.
Right.
You can talk, to talk to the computer. Instead, you typing a lot of 1 or 0. That didn't make sense. Okay? So in the computer system, all one they can using the octal. However, now they will be most of the new one using the hexadecimal only. Either they do the same job. Okay? Now the first thing we're talking about binary to decimal conversion. So if you get a binary number, and human does not deal with the binary, human would deal with the decimal. So that's why somehow you need to convert it into the decimal. Okay, I given you example. You get 0, 1. That is a binary number. So we need to know how to convert it to decimal. So the first thing, you take this one number times 1 times 2. 2 to the power, what power?
3.
Yeah, you on this point right here. And now how many bits left over? 1, 2, 3. So power of 3. Then you adding another one here. Okay, basically it have to be 1 times 2. What power?
2.
2. Okay, and 0 we don't care. 0 times anything will be 0. So I can adding to this one here. 1 times 2. Okay, 2 power of 3 equal 8. That means 2 times 2 times 2. You adding 2 power of 2 will be 4. Then you adding 2 power of 0 is 1. So they will be equal number 30 in decimal. And make sure if you're confusing, you're not quite following, let me know. Okay, so they get the binary, and we are human. We're using decimal. So sometimes you want to know what the decimal equivalent. Okay. Next one, they given you number 25 in a decimal, and they want to know what the binary. I just given to you to know how to do it, but we're not using it. Okay. If you go to the college, then you have to do. In here, we are the technician, hand-on training. Something really don't need it. So if you get a number 25, then they asking you what the binary. Then you can say you can get a equivalent will be a 11001. Then you have to go backward, okay? 1 times 2 power of 4 plus 1 times 2 power of 3 and a plus 2 1 times 2 power of 0. That's why you get 25. But you just know we never coming back with that thing, okay? That's not really need for this program. Decimal to binary conversion. Okay, so basically this one we don't need either. But in the college, they asking for you. So they given you the decimal and you know what the binary conversion. First thing, number 25. Then you take 25 divided by 2. And you get number 12 and remaining will be 1. Okay, then next you take 12 divided 2. You get 6 will be what number? 0 remaining, right? Then you take 6 divided by 2. You get number 3 and remaining will be 0. and you take 3 divide 2, you get 1. Remaining will be 1. And 1 divide to 2, you get a 0, remaining to be 1. Okay, so the binary equivalent going from top to the bottom, you get 1, 1, 0, 0, 1. That is how you converting from the decimal to the binary.
Mr. Pham, to convert, you always has to use 2?
Yeah.
Okay.
But that for anyone go to the college, then you have to hit it. In here we don't need. Now, next one. They say converting height to decimal. So you get a number, okay, 356 base 16. That means height decimal. Okay, and they want to know how to convert into the decimal. Okay, so you take 3 times 16 square, power 2, plus 5 times 16 power 1, and 6 times 16 power 0 to get 854 base 10. Okay, that's just showing you how to do it, but I said again, not practical in this program. But the next one will be important to you. Height decimal into binary conversion. You get a number 9F2 base 16. They want to know what the binary. Okay, and now in here you can see they said require binary 4 bit. Okay, for 8 digits in hexadecimal, you get a number 9 in the hex. Okay, you want to know equivalent in the binary have to be 4 bit. They will be 1, 0, 0, 1. I will be giving you the table. Okay, when you're looking into the table, you can see hexadecimal will be equivalent to what binary. Okay, so the answer, okay, let's say 9F2. So number 9 will be 1001. Must be 4 bit for each digit. F will be 1111. And 2 will be 0010. That's very important to you. When I given you the hexadecimal, you have to tell me what the binary equivalent. Make sure if you get any confusing or question, go ahead, okay? Make it clear for everyone. And then next will be a binary to height. So you get the binary and you want to know hexadecimal number. The way to do, from the right to the left, divide to 4 bit for each group. Okay, let's see. 1, 2, 3, 4. That one. 1, 2, 3, 4. Next one. Okay. Then you converting for each group. 1, 0, 1, 1. If you get a table and you understand that will be B. Next will be 1, 0, 1, 0 will be A. And the last 1, 0, 1, 1, 0 will be C. So that will be equivalent to be a 6 in hexadecimal. Okay, any question? Too easy, right?
Just like the practice quiz.
Yeah.
Too easy, Mr. Pham.
Octal to binary, we don't care, but you can read it. They say 3 bit for each root. That means you're going from right to the left, divide into 3 bit. Okay, 1, 2, 3, 1, 2, 3. They're now converting for each root. The first 1, 0, 0, number 4. 1, 1, 1 will be number 7. 0, 1, 0 will be number 2.
And you can imagine those as 4 bits. You just put a 0 on the end of each of those.
Yeah.
Super easy.
Binary octal. So same thing. Okay, you divide by 3, then you convert it. But we're not using here. Okay, next BCD code decimal. BCD stand for binary code decimal. What that means?
It's like
Binary code decimal.
It's like a literal conversion of the numbers,
Now that means
digit by digit.
that only telling you they are binary, but they working like the decimal. That's why they get a binary code decimal. You get a binary, but they working like the decimal. Okay, now when the number, letter, or words are represented by special group of symbol, that equal and coding. If each digit of a decimal number is represented by binary equivalent, this produce a code we call a BCD. 4 bit is required to code each digit. Okay, so now you can get 874. Okay, then you can convert it into the BCD. First thing, each digit, they must be 4 bit in the binary. Number 8 will be 1000. Number 7 will be 0111. And number 4 will be 0100. Okay, now that's only telling you one thing. They still binary. However, in a BCD, you cannot get any number greater than 9. The thing is that we said they working like the decimal, and the decimal cannot get any number greater than 9. Okay, and the next one, the XZ3 code performing the same as BCD, except that will be 3 added to each decimal digit before encoding in the binary. Okay, so number 48. Okay, number 4, and you adding 3 will be number 7. Okay, so number 8. Okay, you adding 3, you can get 11. And this code here we're not using. Alpha numeric code, ASCII, stand for American Standard Code for Information Interchange. Basically, that inside your keyboard. Okay, that means the table converting alpha, okay, A, B, C, D, and the number to the binary. So when you type in A, they converting to the binary so the computer can understand. If you go into the Google and type in ASCII, they give you the table. That table basically inside your keyboard. Okay, when you're typing anything from keyboard, they must be converting into the binary. That's it. Now, when we're talking about the binary only either 1 or 0. But if you're working on the electronic circuitry, combined digital and electronic, and you're looking for logic 1, no way, okay? They don't have any 1, any 0. So that's why they said in electronic, a binary represented by the voltage or the current, okay? Normally we deal with the voltage. If you're looking into the table, this is the table right here. Okay, that's a basic definition. Okay, they can get the voltage minimum and voltage maximum. That will be telling you when you get any voltage higher than 2 volt, less than 5.5 volt, they will be defined as logic 1. And any voltage less than 0.8 volt and 0 volt, they will be a logic 0. So when you measure the some at the point A, for example, you get 3.5 volt. Then what A equal?
Logic 1.
Exactly. 1. Okay, we do nothing with any measurement. Only thing you must be deal with would be logic. Okay, if I say B equal to 0.5 volt, what B?
Still 1.
So 1, yeah.
Okay, B will be also logic 1. And now, when you deal with the circuitry, doing anything, you have to using logic. For example, if I say A or B, then what you think? You cannot take 3.5 adding 2.5. If you adding, what you get?
1, I think.
You get 6 volt, right?
Yeah.
We don't have a logic for 6 volt. You don't have, only thing is you get any logic higher than 2 volt, less than 5.5 will be 1. Okay, so we do nothing with your measurement. You have to only deal with logic, 1 or 1. Okay, equal what?
1.
1.
2.
0 carry the 1. 0
carry
carry the 1.
0 carry the 1.
Oh, okay.
Okay, depend. Okay, we're talking about later. However, they cannot be equal to. Why? The thing is we don't have a number 2 in the binary. In the binary, you can get 1 or 0 only. So you understand that? So when you're working with the circuit, okay, you can get the voltage. However, they have to be converting into the logic. Logic 1 or logic 0.
You can't have a 1.98.
No. Okay. So now if you measure, you get A equal 1.5 volt. What happened?
Can't
Uh,
use,
Isn't it still logic 1?
That's low.
high impedance.
Yeah.
Now, let me, you don't have any 1.5, right?
right.
You can get 0 to 2 or 0.8 to 0. Okay? So that will be telling you your circuitry got a problem. We don't have any logic for 1.5 volt.
You got to backtrack and find out where that started at.
Right. So we don't care. Okay? You're wrong. I know something must be wrong in the circuit. Okay, so basically this one they call a TTL logic. TTL logic. You can see right here. TTL logic. TTL logic means transistor logic. Okay. However, later on you can get a different type of logic, CMOS logic or whatever. The voltage will be minor different. Okay. But this is a very, very basic. When you measure any voltage, they say unacceptable. That means something wrong with your circuitry. Okay. And then now they will be displayed to you the clock signal. Let's see. The clock signal, it looks like the square wave. You can see what the difference between the clock signal with the square wave. What the difference between the clock signal and the square wave? Square
The
wave,
square,
There's a gap, long gap and all.
there's a square wave here. Same thing, right? The difference between the clock signal and the square wave is square wave, you can get a positive voltage peak and a negative voltage peak. However, the clock you get only two values. They can be 0 will be logic 0. And 1, they can be 5 volt or 4 volt. You can see that they don't have a negative.
can you repeat one more time, sir?
What I'm saying is clock signal different from the square wave. The thing is square wave get a positive and a negative voltage. For example, minus 10 volt and plus 10 volt. And the clock signal, they
Is
don't
it the
have
high or
any,
low?
they don't have any negative voltage. They
Is
got
it
they get only 2 voltage,
high or low?
high or low. Low means 0. High means 5 volt. They can be 4 volts still high, but only 2 logic, either 0 or 1.
Can you draw a picture of that one, a figure?
Draw what?
Wave.
Draw-
How the clock wave?
I think he
clock
wants you
wave-
to draw where the 0 volt line would be for the clock, but it's where the 0 is.
They
It's
can,
either-
Oh, is a matter.
Clock is
can
either
be-
on or off.
okay, you can say they can be this one. Okay, I can write the clock here. Okay, that will be 1 and that will be 0.
Oh yeah, I got it now. I got it.
Okay, doesn't matter they start 0 or 1. However, either they can be, for example, 4 volt and 0 volt. You understand logic 1, they can be from 2 up to 5.5. but they prefer logic 1 will be 5 volt.
And Mr. Pham, quick question.
Yeah.
If you did have an input voltage of 2 volts, even though that would be a 1 technically, you would have some sort of buffer circuitry to build that up to 5 volts?
Yeah, that depends on the design.
Okay.
But what I'm saying is, logic 1 going 0, 2 volt up to 5.5, but they want it to be 5. Okay, so sometimes input you apply really weak for logic 1. You get 2 volt, so that's why they not be adding buffer to bring it up to standard 5 volt.
Thank you.
Mhm. And another one, they display the bit sequence, okay, represented by the waveform. Okay, so the first one, you can see 0, then a 1, then a 0, then a 1. Okay, they can be any different cycle for the period. You can see that bit time. Okay, that means one period T. Okay, and if you get the complete cycle, you're able to calculate the frequency. This just basically by a definition. You have to understand and memorize those things when you deal with the digital. For next one, they get only one going from 0 to 1, then go back to 0. You see, this one, 0, then go 1 and go back to 0. That's what they call a positive going process. Only one and no more. Okay? And by definition, the side going 0 to 1, they call a rising or leading edge. And the one from high to low, they call a falling or trailing edge. Okay? And the time from T0 to T1, basically this is just the width of the pulse. Okay? For the circuitry, you can design the width to be 1 microsecond, 2 microsecond by anything. Okay? And opposite to that, you can get this one, negative going, negative pulse. So also the definition for falling or rising edge, okay? Now, a portion of the periodic digital waveform is so, okay? The measurement are in my millisecond. They want to know the following, a period, okay? So now if you're looking on this thing here, okay, period, that means going from here to here, 1T, okay? And frequency, if you get a T, you're using formula F equal 1 over T, you're able to get the frequency. Only thing in here, they bring it up, if you want to calculate the duty cycle, then they take a TW right here, okay? Divide to period T time 100%.
And Mr. Pham,
Now, I asking you that one. Okay, what the duty cycle for that?
50%.
Positive.
50%. Okay, that means that here and here, they equal. Okay? And now, if they draw that one, okay, tell me, duty cycle.
Maybe 80-20.
So that duty cycle will be
80-20, 60-40.
80%. The thing is, sometimes in the view they asking you, okay, I want the clock for 80 duty cycle. Then you have to draw that one. That is 50%. Normally you see 50%. Okay? But I'm guarantee, make sure you understand when they asking for 50% duty cycle, 20% duty cycle, or 80%, how can we draw it?
Hey, Mr. Pham,
Yeah.
sometime back to your clock pulses, where you got the high pulse or low pulse, you can use the clock sometimes and flip those around, correct?
Right.
Okay.
But the thing I said is the last chance for your guys to understand. The
Mr.
digital
Pham, can you please explain the 50%? Like, how do I know it's 50%?
that means the one okay, you can see the one high and the low, they are the same. That's why 50. Okay.
The distance between the rising or leading edge to the falling edge is pretty, you can use that to kind of somewhat determine.
Okay, now is it recognized? You see the high here. And this is the low here. It's the same.
Yeah.
That's why 50. Now, if you're looking on that one here, the high will be more than low. From here,
Oh, I see.
okay, to here, that's the total 100%.
Yeah.
And now I estimate that high for 80. So that's why 80%.
All right.
Okay?
And you would read that the
Alright.
same way for a positive going or a negative going pulse.
This is.
For the positive or negative, reader doesn't care on
Doesn't
the
matter.
duty cycle.
Right. Thank you, sir.
The thing is only for the clock.
Well, then, Mr. Pham, another question be, since they're asking that, is why do we need a duty cycle? What is the purpose of knowing
Now,
the
depending on the circuitry they design, that means they're going high, then they take a longer time to going low.
Okay.
Okay, that depends on engineering and depend on the circuitry. It's hard to say. Okay, now, next thing. We're talking about serial data and the parallel data. For the serial data, that means you need only one wire going from the sending device to receiving device. Only one wire, but you can send too many bits. Okay? They can send too many bits, 8 bits, 16 bits, million bits, doesn't matter. Only one wire. So you know where they're using that serial data. Where the application for the serial data. That is a telephone line in your house. You understand when you're talking on your phone, that means you're sending device to your friend. So when you're talking, the binary will be transmitted, okay? And they need only one wire. They can handle for too many bits, okay? That will be telling you one thing. When the data transfer from one place to the other place, they're supposed to be in serial. Why? I'm telling you. Next one, parallel data. Sending device receiving. If you want to send 8 bits, you must get 8 wire. 1 bit will be require 1 wire. Like they send 10110010. 8 bit, they need 8 wire. So when you want to transfer about 1 million bit, how come you get a 1 million wires? No way. So that's why they have to using the serial to transfer from one place to the other place. But parallel data will be using only inside the computer. So that's why when you buy the computer, they're asking you how many bits you want. 16 bit, 32 bit, and now will be 64 bit. When you say 64 bit, that means inside your computer, they get a bit 30, 64 wires. Okay? So that only happens inside your computer. Anything going out of your computer, they have to be converting into the serial. Okay? Anything when they come in to your computer, that serial must be converting into the parallel data. Computer cannot understand the serial.
Sending series, receiving parallel.
You get that?
So you're saying serial out, parallel in.
Right. Serial, no. Serial in must be converting parallel before they come in the computer. And when the computer is sending out, then parallel must be going out. Then they have to converting back to serial for transmitter.
So all the data that we're sharing in this Zoom meeting is going out of our computer's serial data, and the computers are reinterpreting them as parallel data internally?
Yeah, internal computer only parallel, not serial.
Cool.
Yeah. So that's why you see that you buy the computer, they asking you how many bits. 64 bit, that means inside they get 64 wires for that data. Okay. So now you understand the difference between the serial and the parallel. Serial outside carrying the data on one wire. However, parallel will be happen only inside the computer. Inside the computer, they do not understand the serial. Okay, I given you the table binary here and the decimal number. Okay, so 0 will be 4 bit on 0. Number 15 will be 1111. Okay, they using the formula 2 power of n minus 1. What that mean? That means if you get a two bit, what equal
2 to the power 2, 4.
4, right? Okay, 4 will be 1, 2, 3, 4. So when they say 2 power up and minus 1, same thing, 2 power up 2 minus 1. That will be 4 minus 1. Okay, now that will be telling you one thing. If you get a 2 bit, 2 power up 2, then the decimal will be only up to number 3. The thing is, in the binary, they go in 0, 1, 2, 3. That's enough for. Okay? For only 4 going 0, 1, 2, 3. So if you get any a binary, any bit you want to know the decimal, then you have to using 2 power and minus 1. I give another example. I get 3 bit, okay? 2 power 3 equal 2 times 2 times 2. What? 8. However, the decimal is not number 8. The decimal will be 2 power 3 minus 1. Only 7. If you're looking on the table here, from 0 up to 15, they will be how many? 16. 16 digits. If you count 1, 2, 3, 4, 5, 6, up to 0, you get 16. However, on the decimal, you can get only 15. That's why they're using 2 power up and minus 1. Decimal on the time will be less than 1. The thing is, binary stuck at the 0. Okay, so this one just something for you guys to get along. This is your calculator. Okay, you get a calculator when you type in number 9. So when they go into the computer, they go to the encoder. Okay, the encoder will be converting number 9 into 1, 0, 0, 1. So the computer can understand that is number 9. Okay? Encoder just a one IC. Okay? That will be inside your keyboard. When you type in number 9, they send the signal into the computer by the number 1001.
Mr. Pham, can I ask a quick question?
Yeah, go ahead.
Going back to where you were talking about how the information that leaves your computer is serial data and your computer will internally turn it into parallel data. Is that the job of the shift registers that we use in our
Right.
EMATs?
That will be,
With
you
the
can
flip-flops
get
inside?
the shift register for the IC. Okay, that means converting from serial to parallel data.
Excellent. Okay, thank you, sir.
Yeah, they get the IC to do it.
So if we dial number 8, that will give us 1000, right?
Exactly.
All right.
The one on the left side, your calculator deal with a human. and the encoder try to converting so the computer can understand. Okay? The computer cannot understand number 9. They understand 1001. That's why they need encoder. And now, another thing, the human cannot deal with the binary. So the computer, when they send data out, they use binary. Okay? In order for the human can understand, they need a next device they call a decoder. That decoder will be connected into the 7-segment display. If you enter number 3 in the binary, they display number 3 in the segment. You can see digital watch, anything, right? They display by the 7 segment. That's for the human, okay? So computer want you guys to know something, then they need to get what device called a decoder. It will be
1000.
displayed on the segment to communication with the human. Okay, anything. Okay, and also I make sure, okay, remind to you, this is the last chance you take the digital theories. So that's why we really care about the assignment for TechII. You're not doing anything. You stay here forever in TechII. Don't ask me why you cannot get certificate. You must be doing your assignment.
So why Mr. Smith is still there for years?
I'm staying forever. I'm gonna be here to 2032.
He's a willing prisoner.
He's the face of electronic tech. You see that on the website.
I'm staying to 2044.
Okay, binary decimal conversion. Convert the following binary number to decimal. So the answer will be 109. Okay? You know how to do it. First thing, you take 1 times 2 to the power whatever number. Then the next one, convert the following decimal number to binary. Okay? So for today, I stop the lecture here. Now I get around 15 more minutes for you guys to do the quiz for me. Okay? Next meeting will be continue. We'll start with the binary addition. Okay, so let I stop share on that guy.
Mr. Pham. Mr. Pham.
Yeah.
So in the quiz, the answer we have to write, or how we are going to write the answer? 1, 2, 3, 4. It's 8. So we have to write 8 here.
Now,
Or
okay.
we have
Now,
to select ABCD. There is no ABCD selection.
If you click on the deal, you'll get the because I already did some of them.
It's like this. I got it. Thank you.
Just click on it.
Okay, I got it. Thank you so much, Mr. Smith.
okay, now try the quiz.
Yeah, I'm trying. Number 1 is 8.
Okay, if you don't get it, you'll be here at 2044 with me.
You get 3 minutes to do 1, 2, 3.
$221, number 2. Number 3, 8046F.
I don't know, after you're done. Okay, we get about 12 minutes. Then I go over to make sure you get the right answer. See, I have to change the way to training. Okay, make sure too many different ways we want to do. Only thing, make sure help you to understand it. And make sure if you're not a TechII, then you have to go to Mr. Tai. Zoom today. Some people can get it done in 1 minute. However, have to understand for all of the students in the program, not, everyone can really understand. If you can do it, that means your assignment, no problem.
Mr. Pam. Mr. Pam, I'm trying to download the assignment, but it shows error.
So error. Oh. Okay, let me get through that. Okay, this one, basically, I given you the table. Okay, one will be a decimal and a binary and also hexadecimal when you need it.
Cannot see Mr. Pham.
Are we taking quiz?
What happened?
We
I
cannot see
don't know.
the answer.
No, you don't have an answer. You enter your answer.
Ah,
Okay? You understand you can type in your answer.
okay. Thank you.
We don't have any multiple choice. Also later you can see in the assignment, you don't have a multiple choice. You must do it. We get only 4, okay, test running. That means you get 4 times 3 minutes, you get 12 minutes maximum.
Mr. Pham, for BCD, we have to make in a group of 3.
4.
Number 5.
From the
Sorry.
right to the left, divide each group for 4 bits,
4 bits.
then converting each group. On number 5, you converting to BCD. Each digit have to be converting to 4 bits in binary. If you can do it without any problem, then you really understand it. Number 8, number 9. If you cannot do it, don't worry. We're not teaching about the gray code yet. So you are only doing number 2. If the people can do number 8, number 9, it'd be fine. Okay, we don't count on that. Next meeting, then you understand how the gray code working.
I'm done.
Okay, so we go to the next one. Last one. Okay. Now, I will go over.
Oh, ya mira eso.
Will be very quick. So normally, you understand the, let's say, insert picture, text. You see that? You can insert the text here. You can recording whatever you want to write down. Okay. So 1008, the answer will be
8.
8.
8,
number
yeah.
8. Okay, that is the answer. Number 8. I make it bigger. Okay. And what happened to binary number to decimal? So basically you have to using 1. Okay. I can copy the duplicate that one. Okay.
221.
Number one, what's the one?
So basically this is the way you take the number 1. Okay. Time to what power?
7.
7. Okay. Then you adding. Okay, you add it. Man. Adding. Okay, 1 time. To power of what?
6.
6, right?
Yes, sir.
Then you adding. I try one more. Adding 1 time. To power of what?
4.
Okay. So 1, 2, 3, 4. And so on. I want to know what the answer.
221.
221. Right?
Yes, sir.
Okay. And now they get the binary here and they want hexadecimal. The way to do, okay, from right to the left, divide 4-bit. Take that out.
Number, well, so number 2 is what, 253?
Number 3. Okay, first thing I say, from right to the left, divide by 4-bit.
So number 3 is 8 David, 4, 6 F. What was number 2? 253?
221.
221.
You see, I already get the answer right here.
I'm all over the place here. So
Okay, now, when you divide that by 4-bit, and the first thing you just converting 8 digits. Okay, converting 8 digits. So the first one is what number?
8.
8,
Okay, number 8. Next one.
13.
B.
Oh, I'm sorry. Yes. Excuse me.
D.
D.
D is
A.
a David. D
D
is a
is a
David.
dog.
Okay, if you don't know, you can see.
Down, go down, you have a table there.
Yeah. Okay. 1101. D, right?
Right.
This is a table. Okay, you get a number 1101. So will be D. Okay. Next one. 01100. Number
4.
4.
6.
Number.
6.
Number.
6.
That is the answer.
Yes, sir.
Yeah.
It's 8D46F. What was number 2?
Number 2221.
221, Mr. Slit.
Oh, okay. I must have added something wrong.
Yeah, wear your glasses.
Yeah.
Okay, number 4. Okay. If you want it,
1111.
okay, F will be 1111. And the next 7 will be 0, 1, 1, 1. Number A, 1, 0, 1, 0. Number 9. You get that?
Mm-hmm.
Okay. Number 5, 170 to BCD. Okay, converting 8 digits by 4 bits. So number 1 will be 0, 0, 0, 1. 7, 0, 1, 1, 1, 0, 1, 1, 1. Easy, right?
Too easy.
Too easy, right? Okay, next number 6, BCD, 2 decimal. Okay,
978.
from the right to the left, divide 4 bits. That will be 4. That will be 4. And converting for 8 bits. First 1001 will be
9.
9,
7,
7,
8.
8. Perfect. Okay, on this one, I'm doing only number 7. I want to say 8 and 9 for night. Convert height to binary. Okay, so basically we're already telling you. Converting 8 digits to 4 bits. 0, 1, 1, 0. That's number 6. B will be 1,
1011.
1, 0, 1, 0, 1, 1, right?
Yes, sir.
Number B. Number D, 1, 1, 0,
1101.
0, 1. And
0,
number 3. Yeah, I want you can do like I do it. That means no big deal to convert it. That will be help a lot when you're doing the lab.
So Ted, you said it's B3?
6B D3.
B is in boy 3, right?
Yeah,
Is grade code something we're going over later?
yeah. Number 8, number 9, save it.
Okay,
Next meeting. I'm not teaching you for a grade code.
yeah, I got you. I just never heard of that. Okay, cool.
Then 11 and 12.
Okay. 10. That's the height, easy one, right? Binary to the height, right to the left, divide forward. Okay, you get B3.
3.
And height here, you want to get to the binary, and they must be forward for x 0, 0, 1, 1, number 3. A will be
A will be 1010
0.
and
And-
5 is 0101.
Right, 0, 1, 0, 1. That's what I want. Just do like I do it. Now binary again. To height, forward, 1, 2, 3.
So C is in Charles, E is in Edward, and then the number
Okay,
8.
they will be C. Okay, E, right?
Right? And then 8.
Perfect.
You got that, Kumi and Viola?
Yes.
You dare to learn for us, Mr. Smith.
Okay. Okay, I'm copying off you guys' paper.
Okay.
Okay, that is it for today.
Thank you, Mr. Pap.
Yeah, no problem.
Okay.
Thank you very much.
Thank you.
You guys understand I find too many different ways in order to help you.
This is hard.
Okay, so we'll see you tomorrow.
Thank you.
Thank you.
You are welcome.